Today's class we will discuss about pressure. So first of all, let me explain you some key concept and then we will do past paper question. For pressure, first thing you need to understand P is equal to F over A. So simply you can say pressure is equal to force divided by contact area, and the force normal to the surface we take. So simply you can say force divided by contact area. And in this case, simply you can replace pressure with P and force with F, and contact area we can replace with A. And the unit of P is Pascal, so this is PA, and the unit of force is Newton, and unit of contact area is meter square. We also need to understand about liquid pressure, liquid. So we need to understand about liquid as well. Liquid pressure, simply we can understand P is equal to rho GH. So I will explain you in detail. So rho, you need to understand what is rho. This one is the density of liquid. So this one is density of liquid, or you can say density of fluid. So this one is the density of liquid, and P is the pressure, and G is a constant. So this is gravitational field constant, and this is 10 newtons per kg. You can use 10 at IGCSE level, and H is the depth. So this is depth. So what exactly it means actually? It simply means that, let's say you have this container. So this is one container, and let's say we have water inside or any other liquid you can assume. So we can simply imagine we have liquid inside this one, and in this case, if question is asking you to find value of P, let's say at this point, we can say this is P1, and if question is asking you to find value of P at this point, we can say P2. So what is the H in this case? H is the height above this point to the surface, mean this height you have to take. So this height, so we can say this is H1. So this is the depth, means distance from the surface to that point. And for this one, the height you need to take from this point to this point. So this height you need to consider, or simply you can say this is the depth. So this one you have to consider. So this is some basic understanding about this one. So let's try to understand this one a little bit in detail, how we derive this formula. So let me explain to you. You can simply imagine we have one cylinder. So this is cylindrical object, and this is filled with water. So you can simply imagine this is water, or you can imagine this is a liquid, and cross-sectional area of this one is A. Let's say the height of this one, height of this cylinder, let's say this one is H. So this one is height. Now in this case, what we need to calculate is we need to find out what is value of P at this point. Value of P at this point. So I can simply say P you need to find at this point. Now in order to find value of P at this point, you can consider this column of liquid, and you can find value of P. Otherwise you can consider this whole cylinder and you can find value of P here, because value of P at this point, value of P at this point, any point it will be the same. So we will consider whole cylinder. So we can say P has to be equal to F over A. In this case, the force acting at this cross-sectional area, that is equal to weight of the liquid. So we can say this is mg divided by A. But m we can replace with density. So m has to be equal to, there is a liquid inside. So we are talking about liquid. So you can replace with the density of the liquid times the volume of the liquid times G divided by A. Now we need to understand we are talking about cylinder. So what is volume of cylinder? So V is the volume of cylinder. This is equal to cross-sectional area times height. So it means volume we can replace with A times H, and this is G divided by A. So A we can cancel with A. So P from here we will get, this is equal to rho GH. So this is how you can find out value of P. So you need to understand this formula is coming from F over A. So F over A you can derive this one. But this is simple point, you understand. Maybe most of you understand this point. But now let me go to a little bit tricky part. So maybe some of you are confused about that part. Imagine that now you have big cylinder here. Now we can take small cylinder. Let's say this is liquid cylinder, or you can say water cylinder. So this is just filled with water. So this is filled with water. So this is filled with water. And now in this case, you can imagine the cross-sectional area of this one, mean this cross-sectional area, let's say this one is equal to A. And the height of this one, let's say height of this one is H. Now if I ask you what is value of P at this point, value of P. Now you see this cylinder is a big cylinder, this one is a small cylinder. So if you need to find value of P, again you will say P is equal to F over A. So F in this case is the weight of the liquid. So let's say M is the mass of the liquid, so the weight of the liquid will be equal to mg, and this is divided by A. We are taking this whole area. You can take any one point, you can take the weight of the liquid in that column, but we are taking whole actually for simplicity. So in this case M you can replace with rho V times G divided by A. A is the contact area, so this A we can replace with small a now, because we said this cross-sectional area is small a. So we can write down this volume, so the volume will be equal to A times H. So we can say this is rho A times H times G divided by A. So this A we can cancel with this A, so this one will be equal to rho H G. So you see is again is the same. If you compare with this one, these two formulae are the same. So what we can conclude from here, that's the point you need to understand. So this is simply telling us P does not depend on, so we can say P, pressure does not depend on cross-sectional area. So this is the point you need to understand from here. P does not depend on cross-sectional area. So this is one point you need to understand. Most of the time this is misunderstood by many students. They are often confused about this. Now the second thing you need to understand, imagine that we have one cylinder. So this is one cylinder. So I can simply draw this cylinder here. So this one is the cylinder. Now imagine that we have another shape. Let's say shape is somewhat like this. So you can imagine this shape. So this is any shape you can draw, it doesn't matter. So I'm just drawing like this so it look a bit nicer. Now let's say the height of this one is H. So this height is H, and height of this one is also the same. Height of this one is also the same. Now the question for you is that in this case, if I ask you what is value of P at this point, let's say this is P1, and ask you what is value of P at this point, this is P2. So in this case, is P1 is equal to P2 or not? Okay, so can you please type your answer? P1 will be equal to P2 or not? You can also consider this point if I ask you what is P here. So is P1 is equal to P2 or not? And they have the same height and they have same type of liquid inside. Okay, so for this one, simply you need to understand P in this case will be the same. P1 will be equal to P2. Why P1 is equal to P2? Because P is independent of shape of the container. So we will say P is independent of shape of container. So this is very important point. P is independent of shape of container. So it is independent of shape of container. So it does not depend on shape of container. So this is the second conclusion you need to understand about this one. So these are some important points about pressure we need to understand. So any question until now, please? If these points are clear to you, we are ready to do past paper questions. Before we do past paper questions, I will ask you some conceptual questions and then we will start working on past paper questions. If you have any questions, please, you can type. If you will not type any questions, I will simply assume that there are no questions. So let's move on to next now. Let's move on to next. So these are the main points. If you need to take some notes, you can take notes here now. Okay, you can take screenshot of this one. If you understand these points, then it's wonderful. We can simply go to next slide. Okay, excellent. So I hope you have understanding of this. Let's move on to next one. So here is a question for you, conceptual question, and very nice question to check your concept. You have understanding of this or not. So this one is a pin, actually thumb pin. So simply this is a pin. Now you need to understand is that if I hold this one in my hands like this with two thumbs, I hold this one. Now can you please tell me which person will experience more force, A or B? So which one experience greater force, A or B? Or the force is the same? So in this case, please, you need to understand if I'm holding something between my finger or between my thumbs, if something is not moving, what does it mean? If something is not moving, it means the force this side means the force on this one applied by, you can simply understand this thumb is pushing this way, so this will apply force on this one this way. So here there will be forced by the pin this way, and they will be forced on this pin this way. So the resultant force on this one is equal to 0. It simply means that the force on A and force on B is the same. So the force on A and force on B is the same because this is in rest. It means no resultant force. So it means two forces are the same. So one thumb is pushing this pin this way, and the pin is pushing back on the thumb to the right, and this one is pushing this one to the right, and this pin is pushing this hand to the left. So it means in this case, we will simply say FA, this is equal to FB. So you can understand 1 point from here. So in this case, force is the same. Wonderful. So how about next one? Okay, so how about this one? Area, simply you understand which area is smaller. So you will say this area is smaller, means contact area. This area is smaller as compared with this one. So this area is large. So we are talking about this area in contact. So simply in this case, A is small. So we will say in this case, A is smaller than AB. So this is the second thing you can write down from here. Now the next one, what you need to understand is, okay, the last one. How about this now? Which will experience more pressure in this case? So you will simply say now, in this case, PA, this is equal to F over AA, and PB, this is equal to F over A times B. But in this case, this area is small. This force is the same. So this P has to be greater. But A is bigger. It means this one has to be small. Okay, so in this case, simply we will say PA is greater than PB because area of A is smaller than area of B. So this is what you can conclude from here. Okay, so I hope this is clear to you. If you have any questions, please write now. You can type your question. If you will not type, I will simply assume you have no questions. Okay, so we have discussed all the points we need for this chapter, and we will do past paper questions right now. Okay, let's go to next. You will see one animation and I will ask you some questions. So let's go to animation now. Okay, look at this animation please and watch this carefully. Then I will ask you some. You see it has shrink, and you need to understand it has shrink in all directions. So you see the size has decreased. So size decreased. So simply we can say size decreased, and size decreases in all directions. So size decreases in all directions. So if size decreases in all directions, it means the pressure, this is acting in all directions. So liquid pressure acts in all directions. So this is the point you need to understand. The beauty of that you need to understand. So this is physics in action in all directions. And the second thing you can understand from here is that second thing we can say, this is one point you need to understand. The second, P increases with depth. So we can say pressure increases with depth. So we can say increases with depth. So when P depth increase, P increases, because we have discussed this one. P is equal to rho GH. So if this increase, it means this will increase because the density of the liquid we are assuming is not changing. Now let's watch one time more and then we go to past paper. You can see physics in action. It is clear to you. Let's go to next now. Let's do past paper questions now. Now we will use these concepts and try to answer past paper questions. So please try to answer this now. Try to answer this one. So in this class, mostly we will be using this one only. P is equal to FA, and for the liquid, P is equal to rho GH. So we will be using these two formulas. So please tell me what is your answer for this question. Okay, please type your answer. Not very difficult question. So vehicle sinks into soft ground. If something is sinking into the ground, that is determined by P. So P is equal to F over A. And the pain you feel, answer is D. Okay, excellent. Answer is D is right. P also determine the pain you feel. And also if something sinking, that also in the ground, sinking into the ground, not into the water, that is also depending on the P. So it means F is the same. So area, for example, if this area we increase, we can decrease this one. So it simply means that the area of the tire we have to increase. wider tires. Okay, so the answer for this one has to be D. Okay, next one please. Now in this case, answer, and you can see in this case now we have two different tires. One is this one. You can see this area is narrow, but this area is wider. It means this area is greater than this one, so this tire we have to use. If we don't want this tire to sink into the ground, we have to use this one as compared with this. So the answer for this one is D. Let's move on to next one. Okay, please try to answer this one first of all by yourself and type your answer please. Try to answer this one please. Okay, please type your answer when you finish. Okay, please type your answer when you have done this question. This is not very difficult. I don't know why you're taking so long. P is equal to rho GH. Answer is C. Excellent. So it has to be C. This one has to Amanda. Okay, excellent. So this one has to be C because when this one increase, it means this will increase because density is same. Okay, not B actually. It does not depend on cross-sectional area, please. It does not depend on cross-sectional area, so the answer for this one has to be B. So it does not depend on this. We have discussed this point at the beginning of the class. So the answer for this one is, answer has to be C. So this is the right answer. It is independent of cross-sectional area. P is independent. So we have discussed that point already. C is the answer. Now please look at this question. First of all, answer by yourself. Type your answer. Okay, first of all, try by yourself. Write down your answer please. Okay, answer is A. Excellent, Amanda. Answer for this one is A because this question is asking you the least actually. So simply means that P is equal to rho GH. So the least means that you have to make this one smaller and you have to make this one smaller because G is constant. So this one will be the least, lowest value. So in this case, it is given to you. Fresh water is less dense than salty water. So this one is the answer. Which one has the highest pressure? So this one has the highest. So if they ask you highest, so this one is the highest. So this one is highest. D is highest. And this one is the least. Okay, excellent. So the answer for this question, simple, good. Well done. Chris, simple. Amanda, wonderful. Let's move on to next now. Okay, so please try to answer this now. First of all, try by yourself and type your answer. Okay, so please type and do question by yourself and type your answer. Okay, please type. When you finish this one, type your answer. Answer is A. Please try again. Try again, please. So let me give you the hint. You need to answer this question. So simply for this question, you need to understand least actually, smallest. And in this case, you see the weight is given. It means the force is given. Area of contact is given. So you need to find P. So P here you can find out. PA you can say that has to be equal to force divided by contact area. Mean the P is equal to F over A. You have to repeat this one for all these values and you need to choose the least answer. So this one is 800 divided by 20. You will get some answer here. And if you do this one, you will get your answer here. And for this one, PC, you have 900. This is divided by 14, you will get your answer here. And for the last one, for D, simply you have to do, this is 1000 divided by 21, you will get your answer here. And then among all these answers, you need to choose the least one, the smallest one. So now tell me what is the answer, please. Okay, so now please tell me what's the answer. I hope you will get this answer. So this one is 40 Pascal. All other answers will be higher than this one. Okay, please, if the answer is B or not. Your answer is B or not. Okay, answer for this question has to be B. So you can check, you can do the calculations and you will find this is the answer. I can do calculations right now in front of you, but we can just go to next. This is how you can find out. I have explained you the process. Okay, let's move on to next now. So the answer is B. Okay, now try to answer this please. First of all, try by yourself and type your answer when you're done. So this is about liquid. So you have to use P is equal to rho GH. Okay, please try first of all by yourself and type your answer. Okay, please type your answer. It's not very difficult one. So the answer for this one, I hope you will simply say, answer for this question has to be A. So this one is the right answer. Depth of water in the reservoir. So as H increase, depth is increasing. Which factor determine? Which factor? So this is the factor. Depth is the factor. Okay, so this determines. Surface area of reservoir, it does not determine because it does not depend on surface area. It does not depend on cross-sectional area. So P, please, it is independent of surface area. So you can understand it is independent of surface area, and it is also independent of cross-sectional area. So these 2 points you need to understand. It does not depend on this, does not depend, and also does not depend on this. P does not depend on these 2 things. And this is how they make tricky question. And also the length of the reservoir does not mean how long is this one, and thickness of dam wall does not. P does not depend on that. So the answer for this one is A. Answer is A. Now let's move on to next. Another simple calculation. Check this one please and type your answer. First do by yourself. So here we are talking about largest value of P, and we are talking about liquids. So it means you have to use P is equal to rho GH. Okay, now use this formula and try to answer please. So you will be using here P is equal to rho GH. You will find PC, and you will use here PD. You will find rho GHD. I can say C, and here you will use PB. So this will be rho GH, and also this is rho C, and this is rho D, and this is rho B. This is HB, and here you will use PA. This is equal to rho of A times G times HA. So you will get your answers here after you plug in these values, and you will choose the largest answer. That value you have to choose. So this is how you can figure out the largest value you have to choose. So the answer for this question, if you do calculations, your answer should be this one. This value will be the largest value. Okay, please check your calculation. Is your answer C or not? Okay, so let's move on to next one. So I hope this is clear to you. Simply use this formula. So the answer is C. This is last question from this topic. Then we change little bit topic, but we will continue talking about the same chapter. So please try to answer this now. You need to understand why the size of the bubble is getting bigger, means why the bubble is expanding when it go up. This is very common observation when we look at bubbles coming to the surface. We will see the size of the bubble get bigger and bigger when it comes to the surface. Why size of the bubble increase? Size of the bubble. So you have to look at this formula. P is equal to rho GH. Density of the liquid is not changing when the bubble is coming up. G is not changing. So what is happening to this one? Height, you will say this is decreasing. So it means this one is decreasing. If I look at this point, for example, the total value of P, for example, if I need to find P at this point, this P is due to this column of the liquid. So I will say it is due to this column of liquid. So I can say this is HW, height of liquid column, and it is also there is atmospheric pressure that is acting on the surface. So 2 type of pressure you have to consider. So this is P atmospheric, P atmospheric, P atmospheric. Now answer is C. Answer is C. Wonderful. Wonderful. Answer is C for this one. So Amanda, okay, well done. Answer for this one is C. So let me little explain to you. P total, this one has to be equal to P due to the liquid. So I can say P due to the liquid, or you can say water in this case, and plus P atmospheric. And P liquid is rho GHW, and this is P atmospheric. Now in this case, you need to understand what is not changing and what is changing. If you look at this now, density of the liquid is not changing, but HW is decreasing. So, but this is constant. So it means this is decreasing. So it means height is decreasing. So we can say water pressure or liquid pressure in this case is decreasing. So the answer for this one is this. So the answer is C. Not answer is A, because atmospheric pressure is constant. Okay, well done. I hope this is clear to you. Let's move on to a little bit different. Same chapter, but topic little bit different. Let's move on to next one. So these 2 instruments you need to understand at IGCSE level. So these 2 instruments you need to understand. Now, first of all, you need to understand about barometer. Barometer. So which one is barometer? I hope you will simply say this one is barometer. And barometer, what is the purpose of this one? What we can measure with this one? Barometer is used to measure atmospheric pressure, please. You need to understand atmospheric pressure. So this is used to measure atmospheric atmospheric pressure. And atmospheric pressure, you can also say this is the air pressure, because this pressure is due to weight of air particles. So atmospheric pressure or air pressure we can measure with this one. And second thing you need to understand, if you look at this one, the white part means in this region nothing is here, so you can simply say this is vacuum, or you can say there are some mercury vapor. So most of the time we say this is vacuum, so P here you can say is equal to 0. Practically it's not 0, but for simplicity we can assume P is equal to 0. So this is vacuum, no water vapors. And so when you need to find atmospheric pressure, which height you need to consider? So you have to take this height from the surface of the liquid in the container to the surface to surface, please, very important. Most of the time student they make mistake. So height is from surface to surface. So let me write on which height you need to take. So better way to understand this height is surface to surface. Surface to surface. One way to remember this one. Surface to surface means that from the surface of the liquid inside this container to the surface of the liquid inside tube. So you have to take this h. So very important and little bit tricky. Many tricky questions just based on this one. So this is what you need to understand about barometer. Now let's try to understand a little bit about this one, manometer. What is the use of manometer? This one is manometer. What we can measure with this one? You can measure with this one gas pressure, we can measure with this one, or simply we can say this is used to measure pressure difference. Pressure difference. We can compare pressure difference. So with the help of this one we can measure pressure difference. So this is the purpose what you need to understand. Manometer. What is difference between these two? So you can see the difference from here. Okay, now in this case, now let me explain to you a little bit more about this, then our class will be over. Now please, you need to understand at the same height here, you need to understand P is the same. So I can say PA, this is equal to PC, because the same level, it means P is the same. And if I ask you what is PA, so you can say PA, this one will be equal to, at this point, this is open to the atmosphere. So it means at point D there is P atmospheric, that is acting down. So PA means at this point this is equal to P gas, means the gas inside this cylinder. This one will be equal to P at, this will be equal to P atmospheric, or you can say P at D, P atmospheric plus due to this column of the liquid. So we can say this is, let's say, P between C and D. Otherwise I can say, I can write on rho, density of the liquid inside this one, I can say density of fluid for example, time G, and time this height, means you can say HCD. So that is equal to PA, and that is equal to pressure of gas. And at this point P is the maximum. So P is maximum at this point, and at this point P is minimum. So these points you need to understand about manometer.